Now here we will consider a problem on a cone which is freely suspended in air by means of a string which is attached at a circumference point on its base circle. Circle is of a 40 mm diameter and height is of a 50 mm. When cone is freely suspended by means of the string, and in freely suspended condition, when this string becomes the vertical, this point passes through 1/4 distance from base along the axis. So as the height of the axis is 50 mm, so this point will along the axis this is axis, and along this axis this point will be at a 12.5 mm distance. So initially draw this top view and divide this circle in 12 equal parts. Then draw its front view showing the height in this way. Show the string position at a 12.5 mm distance from base of a cone. Now in final freely suspended condition, the string should be the vertical. So draw this vertical line, and on this vertical line locate this point which is a center of gravity. Means measure this distance and shift this distance here, and locate this point by using the compass. Redraw the same front view in freely suspended condition. Then its top view will become as like this one. So to draw this base which appears as an ellipse, we have to take the help of the projection points from this top view, and in it also the projections from the points in downward direction. So the corresponding intersection gives us the points for ellipse. Join all these points and thus we will get the final top view when the cone is freely suspended in air. So as per problem statement, that is freely suspended cone in space in which the string is attached to the base of a circumferential point. So initially assume the axis of a cone is a perpendicular to HP and vertex is in downward direction. So initially draw its top view. So as the diameter of the cone is a 40 millimeter, so mark the center point, then take the distance of a 20 millimeter in compass. Take this center and draw this circle which will indicate the base of a cone. Now we have to divide this cone circle in 12 equal parts. So take such as a center point and draw arcs which will cut the circle at two positions. Then lastly take this center point and cut this. Let's mark this as a point 1, 2, 3, 4, 5. Now for a front view, as the axis height is a 60 millimeter, so locate the axis height in front view, then draw this base and join these points, which are the generators of a cone. Now shift all these points in front view so this is a point 1, this is a 2 and 12, this is a 3 and 11, this is a 4 and 10, this is a 5 and 9, this is 6 and 8, and last one is a 7 point. Now draw this axis. Now as the given cone is freely suspended in here, so as the height is a 60 millimeter, so 1/4 of this will be the millimeter, and through this draw the string position. So this is a CG along the axis, measure from the base, which is a 15 millimeter. So this is axis height, which is a 60 millimeter, and this is a string. This is a point of center of gravity. Now as it is freely suspended, this string becomes the vertical. So by considering this situation, we have to redraw the same front view in this condition. So draw the vertical line which is perpendicular to the XY. Now on this line locate these 2 points, that is a 1 dash and CG. So let here will be the 1 dash and take this distance in compass This is a CZ. This is the point of a center of gravity. Now we have to mark these 2 points. Let this be the V and this is a V dash. So we have to locate the V dash and say 1 dash. 1 dash and CG is located. So to locate the vertex V, measure the distance from 1 dash and cut the arc to this side. Now take this distance in compass. Take the center and cut it here. Then to locate the 7 dash, take this distance in compass and draw the arc to this side. Take this distance of a 7 dash from CZ and transfer this distance so this will be the point. Now join these points by straight line. Now draw the axis. Take this distance in compass and mark the axis. Then already we have got point this V dash, so take this distance in compass and it will cut here. So V dash is available and point 7 dash is also available. So join these points. Then draw this axis. Now shift all these points on this base. From 7, this with the point here. Now take this and mark the point here. So 2 dash and 12 dash is located. This 6 dash, 8 dash is also located. Now to locate the 3 and 5, take this distance in compass, mark this point, take the center and mark this point. So that will get this point, that is a 3, 11, 5 dash and 9 dash. The middle point will be the 4 dash and 10 dash. Now locate all these points for top view. So first we'll locate the point 1. The point 1 will is here. 1, then 2 and 12. 2 is here, and 12 is here, sorry, 2 and 12, 12 is here, now 3 and 11. So for 3 and 11, draw this vertical line. So from through the 3, cut this line, we will get this point 3, and this 11 will be the here. Now next is a 4 and 10. So for 4, this will be the 4, and the 10 will be the here. Now 5 and 9. So this is a 5, and this is a 9. Now 6 and 8. 8 and 6. Last will be the 7. So through all these points, draw ellipse by using the French curve. So align the French curve. Now look at the vertex B. And then draw tangent to this ellipse. Then draw the axis. So the solution is completed.